So you will replace A. A is 1 minus 2, 5, 3. Minus 2 into B. 1 minus 3, 4 minus 7. Plus 6 times I. What is I? What does I stands for?
Unit
Unit matrix. 1, 0, 0, 1. That is equal to 1 minus 2, 5, 3. Take a 2 inside. 2 minus 6, 8 minus 14. I did not take minus 2 inside. I took only 2 inside. You have the option of taking minus 2. If you take minus 2, then become plus. Then take 6 inside. That means all the elements should be multiplied with 6. Now we can add all together. 1, first element 1, second element minus 2, third element plus 6. Again here, minus 2, plus 6, and plus 0. Then 5 minus 8 plus 0. 3 minus of minus 14 plus 6. So your answer became 7 minus 2, 5. 6 minus 2, 4. 5 minus 8 minus 3, 23. Yes, let me see who has given the answer correct. Yes, Baivo Mishra has given the answer correct. Is it clear?
Yes, sir.
Yeah. Can we move to next problem? This is a very easy topic, so I'll just do few questions first. Because multiplication is the difficult part. Let's do fifth question. Fifth question. 3x minus y is 1 minus 1 minus 1, 1. Below it, x minus 3y equal to 0 minus 1, 0 minus 1. So you will apply the same method as that of simultaneous equation. So if I want to solve this two equation, what will you do? You will multiply the first equation with, let's say, second equation with a 3.
3.
So can I write this way? 3x minus y is equal to 1 minus 1 minus 1, 1. When you multiply this with a 3, it becomes 3x minus 9y. But when you multiply this with a 3, every element will be multiplied with 3. Is that clear to everybody?
Yes, sir.
Now what do? You subtract. When you subtract, the sign changes.
3x will get cancelled.
8y is equal to 1 minus 1 minus 1, 1 minus 0 minus 3, 0 minus 3. I hope you can read it. Use some other color. So 8y will be equal to 1 minus 0 is 1, minus 1 plus 3 is 2, minus 1, 0, and 1 plus 3 will give you 4. So y is equal to 1 upon 8 into 1, 2, minus 1, 4. So y is equal to 1 by 8, 1 by 4, minus 1 by 8, and 1 by 2.
Sir, it should be 1 by 2 now.
Which one?
Where you have written 1 by 4, there it should be 1 by 2.
No, here 2 by 8, no?
Okay, so it will
By
get
8
cancelled.
is 1 by 4. Here minus 1 by 8. Here 4 by 8 will give you 1 by 2. Now we have to find x value. So x you can take from one of the equation. Let's take this equation, second equation. X is equal to 0 minus 1, 0 minus 1 plus 3y. Now put this y back here. So x is equal to 0 minus 1, 0 minus 1 plus 3 times 1 by 8, 1 by 4, minus 1 by 8, and 1 by 2. Since I don't have much space to write, I'll have to manage it here. 0 plus 3 by 8, that is 3 by 8. Minus 1 plus 3 by 4 is minus 1 by 4. 0 minus 3 by 8. Minus 1 plus 3 by 2 is 1 by 2. That is the answer for x. So the same way as simultaneous equation, only thing is you have to multiply. When you multiply a matrix with a number, every element should be multiplied with that number. That's it. So what I did, I added a and b, a plus b I calculated. Now I am checking whether ab is singular or not. When do you say matrix is singular? Anam?
When its determinant is equal to 0.
Yeah, so calculate determinant of a plus b. So determinant of 3i, 3i, minus 1, minus 1. What answer you'll get? Minus 3i plus 3i. So
Then it's
determinant you
0.
got as 0,
0.
which implies a plus b is a singular matrix. A plus b is a singular matrix. Now what happens in a minus b? You check yourself. Try to do a minus b yourself. So when I'm calculating a minus b, this middle sign will become minus. And calculation will become what? I minus 2i minus I.
Minus
2i minus I. I
minus
minus
5
and 5. So determinant of a minus b will be minus 5i plus 5i, correct?
Plus 5i. So that also is singular.
So
Because
that
you
is
get the
also a
determinant
minus
as
b is also singular. Yes, 6 students have given me the answers. Tasin, Chirag. Yes, good. Who else? Anam, Parinita. Good. Okay, now I think this type of problems are quite easy. There's nothing much to teach you in this. This is also you can do it yourself. Okay, we'll go for multiplication. This is a difficult part. So this you'll do more problems in this exercise. You have to practice yourself, otherwise you won't learn it. Let's do the first problem. You got to multiply 3, 2, 1 with 2, minus 4, 3. First, you tell me what is the order of the first matrix? What is the order of the first matrix?
3 into 1. 3 by 1.
Second,
3 by 1. 1 into 2.
1 by
1 by 3.
so your
1 by
answer will be
3 by 3.
3 by 3. So first you calculate this. What is the answer?
Yes,
Then if it is 3 by 3, you will have 3 elements here, right?
Yes, sir.
3 here and 3 here.
and 3 here.
Now what do? You fill it up. How do you fill up? This element is obtained by multiplying the first row with first column, in which this element belongs to which row? It
First
belongs
row
to
and
row
first
1,
column.
and it belongs to column 1. So row 1 will multiply with column 1.
Column 1.
So what answer you will get?
6.
6.
6. Then row 1 will multiply with column 2. So 3
Minus
into
12.
minus 4.
12.
Then 3 into 3,
9.
9. Then comes second row. So your multiplication start from second row. Second row with first column. Then second row with second column. Second row with third column. Lastly, third row with first column. Third row with second column. Third row with third column. So that is your answer. Yes. Yes has given correct answer. Kevil has given correct answer. Vaibhav has given good. Understood the first part?
Yes, sir.
Please do yourself this problem. The same way, first you will calculate the order, then you will calculate the value. Now you will be multiplying 2 minus 1, 3 with 4, 3, 1. What is the order of this matrix? 1 by 3.
1 by 3,
By
3 by 1.
1.
So your answer will be 1 by 1, which means there is only one element.
Yes, sir.
Only one element. And how do you obtain that one element? First row with first column. But there are many elements in this rows and this column. So first will multiply with first.
Okay, sir.
So first will multiply with first. That means 8. Sleeping versus standing. First sleeping with first standing. Second sleeping with second standing. Third sleeping with third standing. That gives you 8 as answer. So it is a 1 by 1 matrix. Only 8 is your answer. Is it clear?
Yes, sir.
Yes, sir.
Yes. So given me the answer. Let me see. Anam has given, J has given. Okay, Yash has given. Everybody followed?
Yes, sir.
Okay. Now the most important thing in matrix. If I multiply A into B and B into A, will it be equal or not equal? In some case they will be equal, some case they will not be equal. So we can't say, it depends on the matrix. So you cannot generalize and say, whenever I multiply A and B and A, they will be equal. Because of this reason, if A and B are two matrices, and if I ask you to expand this, how will you expand A plus B the whole square? Meaning of A plus B the whole square in matrix is A plus B multiplied with A plus B. So naturally, first A, this A, multiply with the bracket. Then B multiply with the bracket. I hope you understood. This A multiplied with this bracket. This B multiplied with this bracket. When you open the bracket, A into A square, AB, BA, and B square. Now you cannot combine this both and write A square plus 2AB. This is wrong. Is it clear to you? So this is wrong. You cannot add them. You have to keep it like this only. So what will be A plus B into A minus B in matrix? What will be the answer for this in matrix? Can you tell me?
Minus AB plus BA minus B square.
A square minus AB
minus AB
plus BA
plus BA
Minus B square.
minus B square.
Can I cancel AB and BA?
No.
No, because they need not be equal matrix.
Hmm.
Is it clear to you? So what's
Yes.
your conclusion from this question number 2? AB and BA may or may not be equal. Hence, we cannot apply any algebraic formula on matrices. Clear? When you are saying A and B are matrices, you cannot apply algebraic formula. Because algebraic formulas are true only for numbers, not for matrices. Is it clear to everybody?
Yes, sir.
Okay, let's start with this first problem. Calculate A into B. Two by two multiply 2 by 2. Your answer is going to be a 2 by 2 matrix. Now write your answers. First row, sleeping versus standing. Keep it in mind, sleeping versus standing. First with first, second with second. So what answer you'll get? 4 minus 9. Sleeping versus standing. 1 plus 6. Then you are moving to second row. So your numbers also, your multiplication numbers also goes to second row. Second row with first column. First with first, second with second. 16 plus 6. Then 4 minus 4. So your final answer is minus 5, 7, 22, and 0. This is AB. Now you will calculate what is BA. So B 4, 1, 3, minus 2. A is 1 minus 3, 4, 2. Now again 2 by 2 with 2 by 2, you will get 4 elements. Now fill it up yourself. Sleeping versus standing. Remember this. Sleeping versus standing. First with first, second with second. 4 plus 4. Sleeping versus standing. Minus 12 plus 2. Now you move to second row, so your subject also moves to second row. 3 minus 8. Minus 9 minus 4. 8 minus 10 minus 5 minus 30. This is your equation 1. This is your equation 2. So from 1 and 2, what's your conclusion?
That AB and BA are not equal.
A and B are not equal. So you can't conclude always they are not equal. For some case they may be equal also. Some case they may not be equal also. Depends on the matrix. So what have you learned? Don't apply any algebraic formula on matrices. Plus b the whole square, a minus b the whole square, a plus b the whole cube. All these formulas cannot be applied on matrix. This is what you learned today's major thing. Three rows and 3 columns. Now we'll start filling it up. Remember, you are going to multiply
Sleeping
first row
versus
with
standing.
first column to get this element. This element is obtained because it belongs to first row and first column. So it is obtained by multiplying first row with first column. I hope that part is clear to everybody.
Yes.
Yes, sir.
So we call it as sleeping with standing. First with first, second with second, third with the third. No repetition. So your answer will be minus 2 plus 6 and minus 3. Can anybody tell me what should be the next one?
Minus 6 plus 6
Minus 6 plus 6,
and 0.
0. Then next one, same row with the third column.
2 minus 3 and plus 1.
Then go to the second row with each of the column. So minus 1,
Minus 1
Plus
plus 2
4.
plus 1.
minus 3. Same row with next column. Then same row with the next column. 1 minus 2 plus 1. Then third row with first column. So your answer will become 1, 0, 0. Then again you'll get 0, 1, 0, 0, 0, 1. All right. What do you call this matrix?
Diagonal.
Diagonal.
Upper triangle.
No, this is unit matrix now.
Yeah, it is called a
Yes,
unit
sir.
matrix. So what you got it? This is a unit matrix. When our diagonals are all 1, all others are 0, we call a unit matrix. What is the speciality of unit matrix? Do you know? If you multiply a matrix with unit matrix, you will get that matrix back. A into I is A itself. Is it clear?
Yes, sir.
Yes, sir.
What about B into A? Now here A into B gave you I. Now you will notice that here B into A also will give you I. If A into B becomes I, then automatically B into A also will be I. In such case, AB and BA will be equal. Very beautiful thing. Yes, yes. Yes. Parinita, good. Yes, good. Yes, good. Okay, BA 1, 3 minus 1, 2, 2 minus 1, 3, 0 minus 1 to be multiplied with minus 2, 3 minus 1, minus 1, 2 minus 1, minus 6, 9 minus 1. Do you know why you call it unit matrix? Why do you call this as unit matrix?
Because the diagonal elements are all 1.
Yeah, and why the unit or identity we call it? Because it behaves like number 1. What is the speciality of number 1? If you multiply with 3, you will get 3 only.
1 will give the
Yes,
number
sir.
itself.
Same way, if A is multiplied with unit matrix, you will get A itself. That's why we call it as unit matrix. Clear? It has the
Yes.
property of unit, which is unit in number system 1, no? So it has a property of that. That is why we call it as some identity matrix or unit matrix. So when you multiply here, can I multiply first row with first column? So minus 2, minus 3, plus 6. Next will be 3, plus 6, minus 9. Next will be minus 1, minus 3, plus 4. Next will be minus 4, minus 2, plus 6. Next is 6 plus 4, 6 plus 4, minus 9.
Minus 9.
Next will be minus 2 plus 4. Next will be minus 6
Minus 6, minus 0,
plus
plus
0
6.
plus 6.
That's 6.
That became 9 plus 0 minus 9. Next
Nine.
became minus 3 plus 0 plus 4.
0 plus 4.
So final answer became 1 0 0 0 1 0 0 0 1. Am I right?
Yes,
Yes,
sir.
sir.
So whenever product of two matrix gives you A, B as I, in that case A and B will be commutative. You can write A, B as same as BA. Is it clear?
Yes, sir.
Yes, sir.
Now is matrix multiplication associative? If A into B into C is equal to A into BC. This property is true for all matrices. If you can multiply three matrices, then A into B, first you multiply A into B, then multiply C is same as multiply B and C, and then pre-multiply with A, both will give you same answer. Is it clear to everybody? Commutative rule is not true in case of matrix, but associative rule is correct in case of matrices multiplication. Let's have a look at next problem. Question number 2. This is also a very interesting problem. They do ask a lot of questions based on this. Let's do this and see. Number 2. This is another case where matrix multiplication is commutative. We are multiplying A into B. A is cos theta sin theta, sin theta cos theta. B is cos phi, only the angle changed. Cos phi minus sin phi. Oh, okay. I thought it was the same thing only. It's not same. Minus sin phi. Then sin phi into cos phi. Let's multiply and see. Again, we'll be multiplying row with column. Don't forget this. Sleeping versus standing. So I'll write cos theta cos phi plus sin theta sin phi. Next one, minus sin phi cos theta plus cos phi sin theta. Next, this with this. Sin theta into cos phi plus cos theta into sin phi. Here minus sin theta sin phi plus cos theta cos phi. What do you call this? What is this? Cos theta cos phi sin theta sin phi? Okay. What it is?
Cos theta minus phi.
Yeah, cos of theta minus phi. Very good. Cos A cos B minus sin A sin B. Cos of theta plus phi.
Plus phi.
Here sin of theta plus phi. Here again cos of theta plus phi. That is my answer.
So that is cos sin theta minus phi.
Which question? Which one?
This,
Sin is here, no?
Yes, sir.
Sin of theta minus phi. Sin cos cosine. Yes, yes. Is it fine?
Yes, sir.
Then what they asked you to calculate further in it? Anything more they have to calculate? Only the BA. Now calculate BA and see. What will be BA? I'll put some other color. I got to write B first now. Cos phi minus sin phi. Then sin phi cos phi. To be multiplied with cos theta sin theta. Sin theta cos theta. This cos phi cos theta minus sin phi sin theta. Next will be cos phi sin theta minus sin phi cos theta. Next will be sin phi cos theta plus cos phi sin theta. That is sin theta sin phi plus cos theta cos phi. This is cos of A plus B. This sin of
A minus
theta minus phi.
theta minus phi.
This sin of,
Theta plus phi.
and last one cos of theta minus phi.
Because plus sign is.
Yeah, correct, no?
Yes, sir.
This one, this one, this, yeah. Now tell me, are they both equal? Are they both equal? AB and BA?
The diagonals.
Are they equal?
The position is changed.
No, elements are, corresponding elements are not same, no?
Corresponding elements
Corresponding
are not.
elements are not same, then are not equal. So from 1 and 2, AB is not equal to BA. I hope you understood this. So what we are going to prove? Distributive law. What is distributive law? A into B plus C is same as AB plus AC. They're called distributive law. Now, what are the metrics given? We'll write down. A into B plus C. First, you will put the matrix A. Then you will put matrix B. So what should be, operation should be done? What which has got bracket should be done.
Bracket 1.
So A is 1 minus 1, 3. Then we have 2, 3, 2. B is minus 1, 0, 2, 3, minus 2, 3. 4, 3. Then we have 1, 2, minus 2, 0, and 4, minus 3. So I took the question from the textbook only. So what you'll do first, you will add B and C. So A will keep it like that only. Now add them up. Minus 1 plus 1. 0 plus 2. Minus 2 plus minus 2. 3 plus 0. 4 plus 4. 3 minus 3. Which is equal to, again, sleeping versus standing. So what is your answer? 0 plus 4 plus 24. Then sleeping versus standing. 2 minus 3 plus 0. Again, sleeping was standing. 0 minus 12 plus 16. 4 plus 9 plus 0. That is 28 minus 1, 4, 30. Understood that?
Yes, sir.
Now we will calculate which one? Now
AB plus AC.
AB plus AC. A will be repeated. 1 minus 1, 3, 2, 3, 2. To be multiplied with minus 1, 0, minus 2, 3, 4, 3. Plus AC. 1 minus 1, 3, 2, 3, 2. Multiplied with minus 1, 0, minus 2, 3, 4, 3. Again, I'll do row versus column. Sleeping versus standing.
Sir, C element will be 1, 2, na? Minus 2, 0. C element.
3, 2, 3, 2. Barabar na? Minus
No,
1.
sir, the second one you repeated it. C is 1, 2,
Yes, sir.
minus 2, 0.
Yes, dear. D is 1, 2, minus 2, 0, 4, minus 3. Okay. Then you multiply this, what you get? Minus 1
Minus
plus
1
2
plus
plus
2 plus 12
and 0 minus 3 plus 9. It became minus 2 minus 6 plus 8. It became 0 plus 9 plus 6. 1 plus 2 plus 12. 2, 0 minus 9. Then 2 minus 6 plus 8. Then 4 plus 0 minus 6. That became 13, 6, 0, 15. Plus 15 minus 7, 10 minus 6, 4, minus 2. When you add this both, I should get the same answer. 28 minus 1, 4, and 13. This is your equation number 2. This is your equation number 1. From 1 and 2, A into B plus C is AB plus AC. This is called distributive law. So what did I say just now? In general, algebraic formulas are not true in case of matrix. So A plus B the whole square cannot be written this way. But if one of the matrix is identity matrix, which is identity matrix, like this one, or like this one, in that case, all the algebraic formulae can be applied. Because A into I is also A, I into A is also A, so this is true. Here, this algebraic formula is not true in case of matrix, but this is true because I in place of B, if you have I, then you can apply the identity commutative property in case of matrix. Is it clear to everybody?
Yes, sir.
All of you have followed? Okay, we'll stop with that much today.
Yes, sir.
Next class, we will take the more problems on it, and I'll give you some problems for homework.